Hello, class. Continuing on section 2.2 in our Trig recorded lectures, we're going to just finish the section. And a lot of it is review because we talked about some of this in chapter 3 already. And so first thing is this idea of using your calculator again. It's always good review. Remember, there's only 3 of the trig functions on your calculator: sine, cosine, and tangent. You also have to make sure that you set it up in such a way that when you plug in radians or you plug in degrees, make sure your calculator is set up. But if you need cosecant, secant, or cotangent, you can't use your calculator directly. So that's why you, for example, find sine and then just invert it, meaning take the inverse, with regards to the fraction. So sine equals 1 over 2. Cosecant would equal 2 over 1. And so, again, we talked about that part of it. So you could see here, you could do some practicing using your calculator in radians or degrees. Another part of trigonometry is all these functions are either odd functions or even functions. And it makes the calculations easier. You have a calculator now, so practicality wise, you would just punch them in, right? But secant, cosecant, tangent, and cotangent are all odd functions, which means that if you plug in, we have t here, I like to think of it as theta. So if you plug in theta or minus theta, you get the opposite values. So what do we mean by that? Well, let me just quickly show you here on the whiteboard. So for example, if you had, we know sine of 30 degrees is 1/2. And given that it's an odd, you don't even, if you plug in minus 30 degrees, it needs to be the opposite. So that would be minus 1/2. And what we mean by an even function, which is cosecant and secant, that the plus and minus angles give you the same output variable. So for example, we know cosine of 30 degrees is square root of 3 over 2. Yep, square root of 3 over 2. And so since this is an even function, minus 30 degrees is also square root of 3 over 2. So in algebra, the most classic even function is y equals x squared. And so if you plug in -1 for x, you get y equals 1. And if you plug +1 in for x, you also get y equals 1. And for example, in the algebra world, y equals x cubed would be an odd function. And you could see if you plug in 1, you get 1. And if you plug -1 in, you get -1. And so that's what we mean by even and odd. And again, calculation-wise, it could make it a little bit easier, but in general, you could use your calculator, right? So we've talked about these identities in chapter 4, but it's always a good review to walk through this again. And so these are all on our basic formula sheet, really important to understand the relationships between all these. And these Pythagorean identities, again, the sine squared plus cosine squared is by far, equals 1 is by far the most important and the one that is actually used most often. So to end this section, I'm just going to do one more example. And in the slide, I'll just read it and then we'll just walk through it. So basically it says, given you have a value of cosine, and they use this t equals 3 over 5. And you're in quadrant number 4. Find all the other values. Well, you can generate the triangle, but let's use the Pythagorean identity. So we know sine squared of t plus cosine squared of t equals 1. So we know sine squared of t. And then we plug in 3/5 here and square it equals 1. So we know sine squared of t. That would be 9/25 equals 1. And so you bring that to the other side and you get sine squared of t. And that would be 16/25. Then you take the square root of both sides. Remember, when you take the square root, you do plus or minus. So this would be plus or minus 4/5. So we're in quadrant 4, right? So think about it. Quadrant 4 is right here. And so the y value is negative. So the plus sign goes away. So cosine of t is 3/5. But in quadrant 4, sine of t minus 4/5. So let's find all the other ones. So let's do tangent. So tangent, remember, is sine over cosine. And so tangent would be 4/5 divided by minus 4/5, sorry, divided by 3/5. So the 5's cancel. And so you see tan of t is minus 4/3. So all the other ones you just kind of flip-flop. So none of them are 0, so all of them are defined, right? So I'm going to get the eraser out, give myself a little bit of room. And so to finish this, let's do cotangent next, right? Because cotangent, excuse me, is 1/tangent. And so you flip-flop that. So that would be minus 3/4. So cotangent of t minus 3/4. So secant is 1/cosine. So you flip cosine. So cosine would be 5/3. So secant of t is 5/3. And so the last one is cosecant. And that's 1/sine. And so you flip sine, and so that would be minus 5/4. So cosecant of t is minus 5/4. Okay, so that ends this section. I think a lot of it is review, but it's very interesting to see the similarities between the definition using a right triangle and the definition using the units.